Pioneer 8 was a spacecraft launched by NASA on December 13, 1967. Its main mission was to study the solar wind and interplanetary magnetic fields. Pioneer 8 was the 8th mission in the Pioneer program, which included a series of robotic missions sent to explore the solar system. The spacecraft was launched aboard an Atlas Centaur rocket from Cape Canaveral Air Force Station in Florida. The launch was successful, and Pioneer 8 was inserted into a solar orbit between Earth and Venus. Pioneer 8 was designed to measure the solar wind, which is a stream of charged particles that flows from the sun. It was equipped with a number of instruments, including a magnetometer, a plasma analyzer, and a cosmic ray detector. These instruments allowed Pioneer 8 to study the properties of the solar wind in the magnetic fields that surround the sun. During its mission, Pioneer 8 made several important discoveries. It was the first spacecraft to observe the solar wind beyond the orbit of the Moon. It also discovered that the solar wind is not uniform, but varies in density and speed over time. One of the most important discoveries made by Pioneer 8 was the existence of coronal holes, which are areas on the surface of the Sun where the magnetic field lines are open and the solar wind can escape more easily. This discovery helped scientists understand the complex interaction between the Sun's magnetic field and the solar wind. Pioneer 8 was designed to operate for 1 year, but it continued to transmit data until August 22, 1996, nearly 29 years after its launch. During this time, it provided valuable data about the solar wind and the interplanetary medium. Pioneer 8 was part of a fleet of spacecraft that were launched to study the sun and the solar wind. Other missions in the Pioneer program included Pioneer 9, which was launched in 1968, and the more recent Solar Probe Plus mission, which was launched in 2018. Pioneer 8 was not without its challenges. In 1970, a solar flare disrupted communication with the spacecraft for several hours. In 1977, a software error caused the spacecraft to go into a safe mode, but it was successfully recovered. Despite these challenges, Pioneer 8 was a highly successful mission that helped advance our understanding of the solar wind and interplanetary space. Its long lifespan and resilience were a testament to the engineers and scientists who designed and operated the spacecraft. In 2019, Pioneer 8 was officially decommissioned, marking the end of its long and productive mission. However, the data it collected continues to be analyzed by scientists today, and it will undoubtedly provide new insights into the nature of our solar system for many years to come. Pioneer 8 was one of the first spacecraft to study the sun and the solar wind in detail. Its mission paved the way for future missions, such as the Solar and Heliospheric Observatory, SOHO, and the Solar Dynamics Observatory, SDO, which continue to study the sun today. The success of Pioneer 8 and other missions in the Pioneer program inspired a new generation of scientists and engineers to explore the solar system. These missions continue to push the boundaries of what we know about our universe and our place in it. In conclusion, Pioneer 8 was a groundbreaking mission that made important discoveries about the solar wind and interplanetary space. Its long lifespan and resilience were a testament to the ingenuity and dedication of the engineers and scientists who designed and operated the spacecraft. Its legacy lives on through the data it collected, which continues to be analyzed by scientists today. Pioneer 8 will always be remembered as a pioneering mission that helped expand our understanding of the universe. The Pioneer 8 mission was not only important for the scientific discoveries it made, but also for the technological innovations it introduced. The spacecraft was equipped with a number of advanced instruments that allowed it to measure the solar wind and interplanetary magnetic fields with unprecedented accuracy. These instruments included a solar wind plasma analyzer, a magnetometer, and a cosmic ray telescope. Pioneer 8 was also one of the first spacecraft to use solar panels as a power source. The spacecraft was equipped with 4 solar panels, each measuring 3 meters in length, which provided a total of 92 watts of power. This allowed Pioneer 8 to operate for much longer than previous spacecraft, which relied on batteries as a power source. Another important innovation introduced by the Pioneer 8 mission was the use of telemetry data to monitor the spacecraft's health and performance. Pioneer 8 was equipped with a telemetry system that transmitted data back to Earth in real time, allowing engineers to monitor the spacecraft's status and make adjustments as needed. The data collected by Pioneer 8 was not only important for understanding the solar wind and interplanetary space, but also for studying the effects of space weather on Earth. The solar wind and interplanetary magnetic fields can have a significant impact on Earth's magnetic field and atmosphere, which can affect communication systems and power grids. One of the most significant events during the Pioneer 8 mission was the solar flare that occurred on August 2, 1972. This event, produced a massive burst of charged particles that disrupted communications on Earth and caused widespread auroras. Pioneer 8 was able to capture valuable data about the event, which helped scientists understand the effects of solar flares on Earth's environment. The Pioneer 8 mission also had important implications for space exploration beyond our solar system. The spacecraft's instruments were designed to study the interstellar medium, which is the matter and radiation that exists between stars. By studying the interstellar medium, scientists hope to gain a better understanding of how stars and galaxies form and evolve. Overall, the Pioneer 8 mission was a remarkable achievement that pushed the boundaries of what we knew about the solar wind and interplanetary space. Its scientific discoveries and technological innovations have paved the way for future missions and continue to inspire new generations of scientists and engineers. The legacy of Pioneer 8 will continue to shape our understanding of the universe for many years to come. One of the unique aspects of the Pioneer 8 mission was its collaboration with international partners. The spacecraft's magnetometer was developed in collaboration with the Soviet Union, which was a significant achievement at the height of the Cold War. This collaboration demonstrated the importance of scientific cooperation and paved the way for future joint missions. Pioneer 8 also made important contributions to the study of the Earth's magnetosphere. The spacecraft's measurements of the solar wind and interplanetary magnetic fields allowed scientists to better understand the structure and dynamics of the Earth's magnetic field, which helps protect us from the harmful effects of cosmic radiation. In addition to its scientific discoveries, the Pioneer 8 mission also had an impact on public awareness of space exploration. The mission captured the public's imagination and helped to inspire a new generation of scientists and engineers. Its achievements were celebrated in the media and the mission became a symbol of human ingenuity and exploration. The Pioneer 8 mission was not without its challenges, however. The spacecraft experienced a number of technical issues during its mission, including problems with its attitude control system and solar panels. These issues required careful monitoring and adjustment by the mission team in order to ensure the success of the mission. Despite these challenges, the Pioneer 8 mission was a remarkable achievement that paved the way for future missions to explore the mysteries of the universe. Its legacy continues to inspire new generations of scientists and engineers who are working to unlock the secrets of our universe and expand our understanding of our place in the cosmos. In conclusion, the Pioneer 8 mission was a landmark achievement in space exploration. It pushed the boundaries of what we knew about the solar wind and interplanetary space, and introduced important technological innovations that paved the way for future missions. Its scientific discoveries and contributions to public awareness of space exploration continue to inspire and shape our understanding of the universe. One of the interesting aspects of the Pioneer 8 mission was its long duration. The spacecraft was designed to operate for 6 months, but it ended up operating for over 12 years. This extended mission duration allowed Pioneer 8 to collect a vast amount of data on the solar wind and interplanetary space, making it one of the most successful missions in NASA's history. The Pioneer 8 spacecraft also had a significant impact on the development of spacecraft technology. Its use of solar panels as a power source demonstrated the feasibility of using renewable energy sources in space, which has since become a standard feature of most spacecraft. Pioneer 8's telemetry system also set the standard for real-time monitoring of spacecraft health and performance, which is now a critical aspect of all space missions. The Pioneer 8 mission was not only significant for its scientific discoveries and technological innovations, but also for its role in international collaboration. The collaboration with the Soviet Union on the development of the magnetometer demonstrated that scientific cooperation could transcend political differences, paving the way for future joint missions and international scientific collaborations. The legacy of the Pioneer 8 mission continues to inspire new generations of scientists and engineers who are working to unlock the mysteries of the universe. Its contributions to our understanding of the solar wind and interplanetary space have laid the foundation for future space missions that will continue to push the boundaries of what we know about the universe. The data collected by Pioneer 8 has also been used to develop models of the solar wind and interplanetary space, which have important practical applications. For example, the data is used to predict the effects of space weather on Earth, which can help to protect satellites, power grids, and other critical infrastructure from the harmful effects of cosmic radiation. The Pioneer 8 mission was also an important milestone in the history of NASA. It demonstrated the agency's commitment to exploring the frontiers of space and pushing the boundaries of what was possible with existing technology. The mission paved the way for future missions that would explore the outer reaches of our solar system and beyond. In conclusion, the Pioneer 8 mission was a remarkable achievement that pushed the boundaries of what we knew about the solar wind and interplanetary space. Its scientific discoveries and technological innovations have had a significant impact on space exploration and have inspired new generations of scientists and engineers. The legacy of Pioneer 8 will continue to shape our understanding of the universe for many years to come.